first of the 2 sessions. I'm going to do another one tomorrow. So if you come out of this session and you're like, wow, this was baffling, I need more information, join the second one and ask me all the difficult questions. But we'll start for now. So my name is Gijs Jansen van Doorn. We're going to leave it at that. And I'm a tech evangelist working for Caroline, who was on stage during the keynote. Caroline's Seymour's team. And today I'm going to talk about digging deep into Zerto 7. Now, I won't be able to go like really deep into every single thing we delivered in Zerto 7. So I'm going to focus on a few key elements that we've done in there. Picture. Guess how old that picture is? Trust me, it's old. Name again, oh, wonderful. So the agenda. So I introduced myself, introduced the topic. We're going to talk a little bit about LTR. So what have we done to enhance LTR? What have we done to actually re-architect it? We're going to talk about Azure scale-out promotion. One of the key things, and I think it's a little bit underappreciated in some of our materials. So we're going to talk about that a little bit. Because that's actually a pretty cool thing we've done. We're going to talk about Zerto Virtual Manager clustering. What is it for? What is it not for? What will it be for? We're going to talk about advanced analytics, and hopefully I'll have some time left to do some Q&A. If not, I'll be around here for the next 2 days, so please hit me up and ask me any questions. So Zerto 7 delivered a lot of new things. For the first time ever, we pre-announced it a year in advance. It was something that was very special for us. It was really exciting. We got really nervous because now it means we actually have to deliver on it. Luckily, we have the greatest developers on earth, and they delivered on it. So we talk about converged DR and backup, adding the Elastic Journal concept to the product, adding LTR enhancements to it. Of course, we kept on improving and innovating in our cloud offering as well. So we had some cloud enhancements in there, platform updates. We changed the UI. We added some of the more user experience type of improvements there. And actually this is something that's continuously happening, advancing our analytics. I'm going to talk a little bit about futures as well. I don't want to take too much away from Lee Kaminsky, who's doing a session, like one of the last sessions on Wednesday. I want to make sure it's really well attended, so I'm going to tease it a little bit. But he's going to talk about some really exciting stuff we're going to do with analytics. Now the first topic is LTR. So what have we done from an LTR capability, from an LTR enhancement, features, what have we added to the product? And hopefully I'll dig into a little bit more detail than you might have seen before. And maybe even during the training. Some of the slides, who did the data protection specialist training? So there's a lot of repeat there, but hopefully I can add a little bit more detail there. So we're going to talk about the Elastic Journal. What do we mean when we talk about the Elastic Journal? Is it a thing? Is it something I can enable? No, it's a concept, but I'll talk about that more. I'm going to talk about index and search, how we added index and search into our product. I'm going to talk about the data protection workflows, what have we changed? And we're going to talk a little bit about the target repositories that we added to it, and maybe some of the stuff we're working on for the future. Now, this is probably a familiar slide for anyone that's using Zerto, is talking to Zerto to start use it, or has seen one of our webinars, but it is our basic architecture. And we have a ZVM that's installed, replicating. We have VRAs that do all the heavy lifting, do all the continuous block level replication. No snapshots. We still don't use snapshots, by the way. We haven't added it to our product. It's still continuous. We have our journal, and everything's happening. Now, one thing I'd like to add when I show this picture is we've added so much to the product. LTR, index and search, you name it. This hasn't changed. You don't need to add additional components. You don't need to add database servers, indexing servers that have SSD drives to make it fast. It's still the same deployment. It's still the same easy to use product, or platform, I should say. So how does continuous data protection work? VMs generate I/O. They write data. We have a journal. A journal records or tracks all those changes and keeps them. It's like a first in, first out queue. So writes come in the journal. We add checkpoints in flight, and those checkpoints are actually points in time you can roll back to. So we've been doing this for 8 years already. Works really well, and our customers start to use it more and more for data protection use cases. So why would I go back to a backup that's 24 hours old if I have a point in time that's 5 seconds old that can recover me with way less data loss? Now what happens when those writes get older? Up to 30 days, and we can store in the journal, we push it off to the replica disk. Now this is where we're going to change a few things, because the journal 30 days might not suit your needs for data protection, specifically from a compliance perspective. You want to keep it for a longer amount of time, for that email you get from a lawyer stating, hey, that deal we did 4 years ago, and a specific email that was sent to this guy offering him loads of money to do it, I need to see that email. So that's more of a compliance issue. You're not going to recover a database as it was 2 years ago because you need to recover something. That's more of a compliance and legal type of thing. Now the journal-based recovery really gives you that continuous stream of all these points in time where you can roll back to, giving you really granular recovery capabilities. And for all the customers in here, that's what you already have. That's what you're already using. And what we're adding on top of that is making it more and more data protection and less only about DR. Now what we introduced last year during ZertoCon, so it's actually a year ago, is the Elastic Journal. And the Elastic Journal is basically a new concept in data protection where we combine the short-term retention piece that we have in a journal, up to 30 days, with seconds granularity, with a more cost-effective secondary storage-based long-term retention copy. And giving you the ability to recover files, VMs, applications, or even entire sites with seconds granularity from the short term, and also giving you the ability to recover VMs and VPGs out of that long-term retention piece. Now, what I like to focus on right now is that overlap piece, because you can have up to 30 days in a journal. I can do daily offloads to secondary storage for long-term retention. That means I have an overlap of like 6 days. And that's a key differentiator, because of the continuous data protection, because of that continuous stream of recovery points, we actually give you an always protected environment. Compare that to, let's say, old-fashioned backup. Do it once every 24 hours. I do it on midnight, it's done at 4 a.m., and then I'm unprotected until midnight again. It leaves you a huge gap. With continuous data protection combined with long-term retention protection, you basically fill that gap with the continuous data protection. So there's never a real unprotected moment. And you can choose where to recover from. Do you need it fast? Does it need to be an entire application set? Do you need to start it up straight away? Use the journal. Use the short-term retention. So it's something that can wait, it's less important. You want to pull it from long-term retention, go ahead. You pick and choose where you want to pull it from. See that I'm not walking too far away from the clicker. Now, when you look at what it looks like in the product, we still have the same old journal. Working? Yes. The journal settings. So where you cover like basically the SLA. It's really focused on getting you up and running quickly, fast again. DR use cases, ransomware recovery, something happened an hour ago, I need to recover from it. It's really the short-term use cases. They are more SLA focused. You think about really short RPOs, really fast RPOs, and really fast RTOs. But what we added is actually the retention policies, the long-term retention policies to offload those points in time to secondary storage, more cost-effective secondary storage, allowing you to keep it for years. You simply configure it daily, weekly, monthly, yearly, more of the what do you call it, grandfather, father, son type of rotation scheme. And you said, I want to do an incremental daily, I want to do a full every week, and then monthly, and then yearly, and to keep them for 999 years, and I'm all set. We'll make sure that everything happens at the scheduled time. You can schedule when you want to start your retention process. It's more of a process, and even though there's a start time, and you think, as soon as you see time, you think about, ooh, backup windows. So I have to do it when no one's working, but I mean, is there actually no one working? I mean, Zerto is 24/7. And when I think about 24/7, every time we talk about 24/7, we think about, ooh, everything has to be up and running 24/7. I'd like to add another component to it. Everything has to be up and running with the same performance 24/7. And I think we've all been in that moment where you receive a phone call, you're in the help desk, you receive a phone call and you say, oh, everything's slow. Monday morning, everything's slow. First thing you do, log into your backup server, check if the backup jobs are still running. But because we're doing it differently, we're actually, I sometimes call it CDP, source long-term retention, like a term to explain that we're not pulling it from your production environment. I mean, backups have been the same for the last 40 years. Don't tell any of the new backup vendors that, but it's true. They're still pulling information directly from the production systems onto something else to recover from. And that's the key thing. That's the key thing that makes it have impact on production performance, that makes you have backup windows, and that is the pain. You don't want backup windows, you don't want performance impact. We have a continuous data protection engine that doesn't have performance impact. We then take it from that continuous, the journal and the replica disk, from the target drive, no impact. So again, you can schedule it whenever you want. Another thing we have actually already for the last 8 years, is virtual protection groups, protecting application stacks instead of a single component of an application. Okay, wonderful. I have a database that's consistent. I take that consistent point in time, put it on disk somewhere to recover. But what if I have to recover that entire application that might have 2 or 3 different database servers in there, Oracle, SQL, DB2, you name it, or something new, MongoDB, Cassandra, and I still have to recover that as one entity in the application. I don't want to recover every single component separately with different points in time. That makes it complex. We added virtual protection groups to recover those applications in case of DR situations, database corruption, you name it. But that consistency is maintained across all those different points in time. So even if I recover an application from 7 seconds ago or 2 years ago, all of those VMs of that specific application will be recovered to the exact same point in time. That's a key thing to remember. There's no one out there right now that can guarantee that. I have a backup that starts at midnight and at 5 a.m. It's good, within my backup window. But the first VM I recover might be timestamp 5 past 12, the last one 5 a.m. That's up to 5 hours time difference. That could be disastrous for any type of application or application stack to recover. How do I recover that? What's going to be my RPO? Is it going to be the midnight one? Is it going to be the 5 a.m. one? How does that work? So we can guarantee that all those VMs will be recovered at the exact same point in time. Now, what does the architecture look like? If you forget about all the colorful things right there, this is what we've been doing already. I have my production site, continuous replication going on, no performance impact, no snapshots. I'm replicating to a target site, or a replica site, or recovery site, whatever you like to call it. And I can use that for DR. But I now have a site that has the information that's on my production site as well. It's only a few seconds behind. I know exactly what changed. So why don't I take that data right there and use that to create long-term retention copies? So what we actually do is we have continuous data protection, go into the second site, and then we have a retention process that uses change block tracking, our own change block tracking. So it's not, we don't tap into something of VMware, no, it's our own change block tracking. And we just copy the change blocks onto a long-term retention repository. And that's basically secondary storage based, but it's also object based. So when I say object-based, I don't mean we support object-based storage. We will, not right now, but basically we turn every single repository into an object store to recover from. And it looks a little bit like something on my next slide. That's the issue when you're not on the laptop. So the target repositories, right now we support two types of protocols. It's NFS, SMB. So anything that speaks NFS, anything that speaks SMB, you can add as a repository, you can start putting your backups on it. We added something special to it, and that's optimization for purpose-built backup appliances. So what does that mean? So my data domain is running NFS, so hey, I select NFS. Now if you run a data domain, select the data domain. Why? Because we tweaked the way we're actually storing the changes that we need for long-term retention on a data domain. It's different than we do for other appliances. Because we've learned that if you store it in this size or this format, it delivers a better deduplication. So that's why we've added those different components to that. So if you have to store ones into an exagrid, please select them. Next step for us is to actually do deeper integration. I'm not going to steal anyone's thunder, so stay tuned for the keynote tomorrow. So we really optimize it for those deduplicated storage devices. Now, what does a repository look like? Basically, it's a big pool of data, all stored in objects, chunks of data. And the only thing we added to it is metadata. And this is basically how an object store looks like. And the metadata contains all kinds of information. One is, okay, what does my VM look like? What's the CPU configuration, so we can recover it? What VPG, what backup set? But also, what did my disk look like when I backed it up? And basically, the disk object maps, and I'll zoom into that in one of the next slides, they show you what blocks I need to recover a disk of a VM. That's part of a VPG. So all the information in there is metadata. Now the goal is, and one of the advantages of doing it like this is that eventually every single repository will be portable. You can export it. We'll take that a step further in some of our next versions. But this is the base, this is the architecture. This is how we start. So basically, we turn every single repository we have, no matter if it's file-based or object-based in the future or whatever, turn it into an object store for ourselves. It's like an abstraction layer in between. So what if I start that retention process? What does it look like? We all know CDP is continuous. The retention process runs at a scheduled time. So this time it starts at 8:30 in the morning. So I have a journal that contains the changes. I also have a replica disk. And what I now need to do is basically read the changes that happened between now and the last time I did an LTR copy. Since the first LTR copy, I will read everything. If it's the second one, I will only read the changes that happened between now and the last time I did a full. So that's incremental, but it's all block-based. So I'll take those blocks or take those changes that have happened, place them in the repository, in that data pool. And as soon as that's done, I will generate a disk object map. Now, I don't think Arnd is here right now. Arnd is our product manager for LTR. So if you want to ask him any questions, if you want to talk about futures, currents, talk to him. He doesn't like this because it's an old map and we're using all kinds of new technology. But hey, I like pirates. So the disk object map is basically a map. So how do I represent the map? It's quite accurate, isn't it? And it's only metadata, but it shows me exactly what a disk looked like on that specific point in time I backed it up or put it on the long-term retention repository. And it's a representation of the entire disk at that point in time. Even though those blocks, the wonderful colors you see there, might be shared across all kinds of other resource points. Because hey, we have a map, we know exactly where to take it from, done. We don't want to upload the same change twice. So that's what we're doing right here. This is basically the metadata. This is the picture of what that disk looked like, so we can recover it and read it from that repository. Now, how do we read it from that repository? Well, first I'm going to show you how we write it to the repository. We have our VRAs, our wonderful scaled architecture that allows us to scale and replicate thousands of VMs. That's one of our unique features. So we are a true scaled architecture. Now, what we didn't want to do when we designed something new was add new things, components to your environment, make it complex, make you want to size backup servers, proxy servers, you name it. So what we decided to do is actually add the component we need to do backups and restores to the VRA. We already have that scale-out environment. Why not use it? That a component is called DSS, Data Streaming Servers, Data Stream Servers, DSS. And that basically reads all the data and stores it directly on the repository. At FS, SMB is what we have right now. Like a quick hint, I forgot to remove those. These are futures. So because we have the access to those disks, we know exactly what changed, we just use that component to write it directly on that repository. That means that every VRA in our environment needs to have access to that repository. The ZVM doesn't have access to that repository, it's the VRA itself. So it's a hard Linux appliance to start with. From a security perspective, that's a little bit better as well, because you can really lock that down. Wonderful. The DSS component is also something we use to restore. Because, hey, we have the DOM, the disk object map right there. So I'll just read that disk object map. I know exactly what I need to read. I just read it. Using the DSS, I stream it through the VRA and, hey, place it in a restore disk and let the ZVM do all the automation orchestration. Again, no additional components, no backup servers, no media agents, you name it. Everything is done through the components we already have, because the ZVM already knows how to orchestrate and create VMs and attach disks to it, so we just give it another source. How am I doing on time? Really well. Now, as soon as I start storing data for a longer amount of time, it becomes really important to also be able to find my data. I want to know where a file existed, when I backed it up, at what points in time, where I need to go to recover it. So what we added is index and search. The index and search is a new architecture. Again, you don't need an additional database server. You don't need additional components. It's site-based right now, meaning that if I want to recover anything that's being replicated to a specific site, I log into that site and search on that site. The next step is, of course, global search. Right now, it's site-based. But the technology we use to actually do it is an unstructured and type of scalable architecture. And I'll dig into how we exactly do it. So I think it's a pretty cool way to do it. It's a different approach to what all the others do, because again, we know how to scale, we know how to work in distributed environments. So if we look at the architecture, and this is what it looks like right now, the index happens through a surface on the ZVM called VBA, and it basically reads the data we need to create an index directly through the VRA from that disk, and we store it in an index file on the index repository. If I search, it's the same service, the VBA, that basically accesses the index files, search through them, and represents the search results through the UI. Now, the index repository. It uses Apache Parquet. It's not this. That's the first picture I got when I Googled Parquet. It's actually this. And Parquet is used in like Hadoop type of environments. So it's built for data analytics. It's actually just a text-based file. It's being compressed to save space. But it's like a column-based type of database file, and you can really search it, and it's really scalable, and it's really easy to use. So we don't need an additional database server. We just use technology. It's unstructured. It's being used in data analytics. That makes it really well fit for the use case, especially if you want to store data for a long, long amount of time. It is going to be portable. That's the asterisk. We're taking steps. We first have to get some runtime, make sure it actually works the way we thought it should work. It actually looks really great right now. And then you'll be able to have a index that is stored with the repository. And let's say something happens, I just attach that repository, and it's instantly searchable as well, without doing all kinds of CPU-intensive indexing, collation, database server, SSD drive, you name it. So that's really powerful as well, because it makes it instant to search. But we've done more than just LTR. I know we talk a lot about LTR, so let's skip that and talk about some other stuff. Cloud enhancements. So we've really changed the way we scale in Azure. And we've done that in a native way, so deep integration into Azure. I think that's one of our greatest pluses, is that we don't support a platform just by adding components that we use on another platform, just change some of the code. Okay, wonderful, it's now running on like agents, running on cloud. We support cloud. No, we actually support the platform in a native way. So using their APIs, making sure we scale according to their standards. We added support for encryption at rest in AWS. So basically, if you recover into AWS, it defaults to EBS encrypted volumes. We've done some great enhancements for cloud service providers, new APIs, billing. We've greatly improved RTO on VCD by switching to the API, allowing us to do some parallel actions. But I'm going to talk about Azure's scale-out promotion right now. And the reason I'm going to talk about it is because in Azure it's a little bit different. In public cloud it's a little bit different. You don't have access to the hypervisor. We can't do all the wonderful magic tricks we do on VMware and Hyper-V. So we need to do it in a different way. So every time you do a failover, we have to create the VMs and promote all the changes that are in the journal to that disk before we can actually start it. Now before we had Azure scale-out promotion, we used to do it with ZCAs. You might have to scale out on ZCAs. Now what we've now done is actually use two services that are in Azure, Azure Queues, and Azure Scale Sets to do this, to scale automatically when needed. So basically what happens is, once you do a failover, the promotion process is done through scale-out sets, through workers, uses messages in Azure Queues, you name it. So basically, every I/O I need to write to a specific disk will be included in messages. Those messages will be put in a queue. The skill set will look at that queue and say, hey, there's something in that queue. I better start doing some work. And it will add workers. The more there's in the queue, the more workers you will have. So that's why we scale out. That's how we scale out in the cloud, using the native integration. As soon as it's done, no more workers. They'll disappear automatically. And that's the power of using a hyperscaler cloud, is you can really integrate with their way of scaling. So you don't need additional ZCAs, it's just done through workers. It's really complex, but it's really cool to see actually in action. Another thing we've done in Zerto 7 is some platform updates. One of them is evacuate host for maintenance mode and host down. So that's for the recovery side. So whenever you lose a host or you need to perform maintenance on a recovery side, you just click evacuate host. It will automatically spread the VMs based on, I think it's load right now, across different VRAs. We've added virtual manager clustering. So I can now have two ZVMs sharing a database and failover between them. And we've added tolerant failover. Basically, tolerant failover means that if a failover is happening and some of the VMs in that failover don't start up, we can still finish the failover. And it's actually using the sub-VPG operations that we released in 6.5. And we allow you to do a subset failover, because it's tolerant to failures. What I'm going to start to talk about is virtual manager clustering. So basically, it uses Windows clustering, failover clustering, and it needs, that's the wrong button, but we're resilient. So no worries there. See? That was fast. Almost like a real failover. So ShareDB needs to be a SQL database, has 2 ZVM instances, and I can switch between them. Now, before we dig into questions, because I can sense a question coming up in the audience for someone that already uses Zerto. What are the use cases? We're all familiar with this one. I was, yesterday when I was trying to get our demo stations to work, I was looking at this for about 45 minutes and decided to go to my hotel. But it's for updating the operating system. You need to have those patches, Patch Tuesday, you want to install them, but you don't want downtime on the ZVM. Switch to the other node, ZVM is up and running again, I can do updates on my operating system. The other one is ZVM upgrades. And now do the ZVM upgrade on the passive node, wonderful, up and running, back, do it on the other one. Right now, it's not for HA use cases. So who was going to ask that? Wonderful. Don't have that question anymore. We're definitely digging into how that works and if we can start doing that in the next feature. Right now, it's for these kind of use cases, for the maintenance type of use cases. Because how do I fill over? I use a command to fill over and fill back. I saw someone take a picture. I paused a little bit. Besides that, Zerto 7, new and enhanced user experience. New UI. Not sure if you checked out the demo stations and the product wish list booth, but we all have Zerto 7 running. It's a new UI, new look and feel. It's a lot cleaner. I had to get used to it, I'll be honest, but I really like it right now. And this is our first step into building an even easier to use interface, optimizing workflows, making sure you have to click less to create VPGs, click less to do failovers, those kind of things. So have a look at the booth if you haven't seen it already. You can click around yourself. We also added new features to our analytics. Now, analytics, as you all know, is delivered through cloud. It's a cloud service that's integrated with your license. This is actually a preview of what it's going to look like. So we're going to basically align all of our user interfaces across everything we do. So the Azure Analytics will have the same look and feel as the ZVM has right now with Zerto 7, et cetera, et cetera. And because it's a cloud-based offering, we can have different release cycles. So there's this What's New button on the top. Check that out every now and then because we update it more often than we do with the ZVM or Zerto, and we add new features to it. What have we added? One of them is storage planning or storage analytics. You can now basically zoom into data stores, go to VPGs, and see storage consumption. So if you go to a VPG, you can click a VM, and it will show you exactly what are protected disks, what are their sizes, what are the journal disks, where are they located, what is the size. If you're doing a failover test, we'll also show you the scratch disk size. So some great enhancements, and you can do that on a data store level, you can do it on a VPG level, you can even zoom into specific VMs. We've added the visibility of disconnected sites. There's an RPO over time graphic. And of course, everything is API first. So anything you can see, you can also pull out of our API and integrate with existing monitoring tools, analytics tools you might use right now to do your own reporting or custom reporting. Who has analytics enabled right now? So all the other ones. It's like one checkbox. And you get all these goodies. If you're concerned about security, there's a security white paper that shows you exactly how we transport it, or how we store it, what we send over the network. That should be enough for most of those CISOs, security officers out there to allow you to turn it on. It's really powerful, and there will be some new cool features as well. And I'm not going to pull this slide up too long, because this is what Lee Kaminsky is going to talk about on Wednesday. No, don't take a picture. This is what he's going to talk about. This is going to be a really cool feature and really zoom into what we can do with analytics and why you should enable it in your environment. timing right now because I have time left to do some Q&A. So, questions. I'll start right there. So the question is, I'm going to repeat every question. I'm not sure if all the way in the back there. When you do ZVM clustering, does it require a second license? Well, it is a second Windows instance for the ZVM. So depending on what type of license agreement you have, yes. Any other questions?
The evacuate host, so it's kind of,
Yeah.
is that only on the record side? Because I've had problems with host and maintenance mode with it.
So question is, evacuate host, does that only count for the recovery side because you had issues with on-prem? It's the use case is recovery side. We've added maintenance mode support into the product and I'll have to look at some of the POs and PMs in here. 6.0 when we started. Which one? The maintenance mode support. So if we put a hosted maintenance 6.0, so if you put a hosted maintenance mode, it will automatically. In theory, yes.
We're on 6.5 when I've had issues with it.
Okay, so we definitely reach out to the product booth and look at it.
Yeah.
So there's some fun things you can do. It depends a little bit on how you use it. There are a few things you need to take into account. Maybe we should tweak timeout settings, but definitely talk to one of our Z experts about that. They could probably help you with that. Yes?
You mentioned that the ZVM clustering isn't at the moment going to be used for HA availability. Can it be used for things like replacing a ZVM or changing out a ZVM, at least? Like that?
So question is, can I use ZVM clustering to change?
Like if we want to build out a new server and have a ZVM on it, without that we have to go through quite a bit of process to not lose the entire site.
So migration purposes.
Yeah.
In theory, I would say yes. It's not the intended use case. Disclaimers. Again, I recommend you talking to Chris Duffy, who's the product manager for this specifically. Sounds interesting. Again, not the use case, but it might be possible because we have a process to go from standalone to a new one. So potentially. Okay, there's loads of questions, so I'm working my way across the room. Yes?
Can you comment on the amount of time it takes to build that up on a resource versus
If I can comment on how long it takes to create a backup,
like instantaneous or, you know?
we're faster than when you use snapshots because we don't have to take a snapshot, calculate CVT, read it from the API. So it's more throughput bound, specifically from doing the retention process, starting the retention process. Restore is right now we have to do like a full restore. So it means we have to read all the blocks from the environment. Again, that's also a little bit bound to throughput. I don't have any exact numbers right now, but as we're getting more and more traction, we'll be able to gather more analytics, and I'll be able to get back to you. The first feedback we did get was that taking the backup is extremely fast and efficient because we know how to handle changes, we know how to track changes, and because there's no snapshots, we can start to read it directly from that journey. So that makes it really fast. I hope that answers your question. Any other questions? I'll move to this side. This is good for me because I need to get some exercise. Is that my timer? Yes. No. Where's the question? Oh.
So we have, we're in Azure, we have ZCAs, and we're on 6.5. To see the improvements in the Azure failover, do I have to update production and destination side at the same time, or can I just update the ZCAs?
So question is, I've got Azure running right now. We have ZCAs. If I want to see all the improvements in RTO, do I need to upgrade both the on-prem side and the ZCAs? Great question. Only the ZCA? Only the ZCA. Most of the intelligence is in the ZCA, and so it makes sense. But I'm glad that Udi is here.
There's a tweak for it too.
A tweak?
Yes.
Two?
There's a tweak to get the RTO time lower on Azure.
So there's multiple tweaks available, but to really get the whole scale out promotion stuff in there, you really need to upgrade to 7. But you are correct. There's different ways to tweak RTO.
Can you index any kind of file system?
Great question. We have an FAQ out there that has the file systems in there. Out of the top of my head, it's NTFS, X234, XFS. That's it right now. So we're continuing to add file systems.
So follow up to that, that was my same question. But
Oh.
what about security rights? How do you handle reading that data inside?
You are so close to the guy that can answer it to you. This is the, Arms that I talked about. There he is. There he is. Red pants. He's the product manager for LTR. I don't think right now we're not doing anything with it, but he'll know how to answer the question.
How's your encryption
How's my encryption?
for your backups?
For the backup. So first of all, right now we rely on the target. So
That's not good enough.
anything can do encryption. So from a storage perspective, so that's what we rely on right now. Like I said, right now, anything for futures, you want to talk to it? All right. But so encryption is a tricky one in backup world.
Yeah, but restore is not, right? So the problem is the restore.
Mhm.
If you're in the business of backing up, you're in the
Yes.
business of restore.
Yes.
If you have my backup and somebody can restore my data,
Yes.
I'm cooked. So I need security around that process, and especially around security with
Yes.
information that's highly sensitive.
I absolutely agree with you. And there's several things we're doing there already and delivering on in 7.5, but definitely have a further conversation with Arndt and maybe some of the developers out there. So the question is around encryption, and if you're backing up, you're actually into restoring, which I agree. You back up to restore. Any other questions? Oh, sorry.
Because of the issue in having the index repository on TDA.
So if there's an issue with having these, sorry, I didn't
So
understand.
if we're using Exagrids,
Yep.
so you're setting up your receiving repository, you try to get a PDB then you get an error, you can do, why, or to target like a sonography or any of this stuff,
So typically, the question is around what could cause issues when I add the repository to my environment. Typically, it's
specific to the indexing repository.
so indexing right now is only SMB. So it needs to be an SMB repository, and you need to set it up in site settings.
Yes.
Yes, yeah. So it needs to be SMB.
And that's
And if it doesn't work, most of the time it's a permissions issue.
from the
ZVM, yeah. That's what you saw in the architecture. Yes.
In versions previous, the bandwidth throttling was handled on a site basis,
Yes.
not per VPG. Have there been any plans to make those throttling settings more granular, where you can throttle maybe per VPG or per minute that's replicated?
Question is, bandwidth throttling is currently site-based. Are there any plans to make it more granular, like VPG-based? I'm aware of conversations there. I don't have any insight on if it's on a roadmap, yes or no timeline. I would recommend you to go to Zerto. There's a feature request piece, and I'm pretty sure it's in there. Vote it up. Have you already done that? Okay, good. So at least we have insight that you want it. So that's by the way, it's a tip for any customer right here. Zerto feature requests. There's multiple in there. Vote. One more question. Yes.
How would bandwidth for VPG differ than the current site-based plus priority?
So how would it differ from? That's a great question. We don't have the feature yet. How I would imagine it would work. So there's some site-based right now, and priority and RPO settings. They all align, and there's algorithms, and you name it. So site-based right now means that every VM shares the same. So if one gets priority, I might get others deferred, so it's a little bit more to manage. Sometimes multiple VPGs might go into different sites that have different connections, even though they're all sharing the same bandwidth limitation. So that's why I think the use case for VPG level bandwidth is being asked for. One more.
How do you make your backup application application consistent?
How do you make your backups application consistent / application aware? That's a whole different session of at least an hour or two. Because of the way we replicate, because of the way we do application consistency, like from our perspective right now, we see that less than 1% of our customers actually doing application consistent, how do you say, checkpoints. I'd love to talk to you about that in a little bit more detail. I see the need for it actually becoming less and less, because if you really want like application consistency and low RPOs, you'll solve it in the application. And application consistency has impact on performance, has impact on how often you can do it, so you'll lose granularity. But like I said, that's asset compliance, databases. I could have a whole different session about that. So if you want to talk to me about that, I'll be around. The answer is not, it's complex, it's complicated. Because I have to close down right now. Thank you very much. We have the survey. Don't vote for him, by the way. That's not me. Thanks, everyone.